Hey everyone, my name is Josiah. I'm one of the officers of a new club at the University of California, San Diego, and we're called Triton Prosthetics, and we're trying to create very affordable, low-costing prosthetic solutions to people with limb impairments. And so yeah, this is the video for in order to get approval to become an approved enable source for these prosthetics. So I'll try to cover all the qualifications. If I miss anything, feel free to comment on the video or just send me a message and I'll try to respond as quickly as I can. So let's get started. So I think first, just an overview of the hand, make sure that it works. You can see here's the open, close it all the way. You can see the thumb and the index fully meet. View. You'll notice that when the actuation is completed and it sort of springs back into its open hand position, the fingers don't fully re-extend all the way. This was one of the major issues with our test print, and I'll go into that later. But yeah, a couple of things that were definitely not ideal that will be avoided in the future. But it was caused by, again, some non-ideal conditions. So, but the clasping fully works, as you can see, and if we have a test object, so say this like deodorant stick, I wanted to grip it, you can grip it, see like that. Try again. There we go. Grip it, see, hold it pretty effectively, release it, grip it, enough force, doesn't break, and release it. Now to go through the different features of the hand. So let's start with the Whippletree. See here. Bends, and you can see that the tension lines are fully constrained, so that when you pull on a little bit, you can see already the hand's moving a little bit. From the back, you can see the screws cleanly placed in there. The gauntlet, you can see the profile. It was thermoformed. Fingers. The joints. And now we can get into sort of the issues that we faced when we were first putting together this test print. The chief issue, and definitely our biggest concern that we definitely will be, but it's easily avoidable, but we definitely made the mistake this first time around, was printing with supports. So all these finger joints, and then a lot of the, and I think even the gauntlet was printed with supports. What we found was we were using the printer, I think it's the BCN 3D Sigma. What we found was that one, the printer can is robust enough that it can easily handle overhangs, so the supports weren't needed. And in fact, the supports ended up having negative utility to the print quality, because when you try to remove the supports, for whatever reason, it might have been the slicing algorithm on Simplify 3D, or it just might be PLA, or maybe the printer itself. But in any case, when we're trying to remove the support material, it's incredibly difficult to do so, and in fact, it impairs a lot of the functions of the component of the parts that were originally attached to the support material. So you can notice, for example, that again, these fingers, they don't fully actuate all the way back. So see how it starts here, close it, it closes fine, but when you open it, it doesn't go all the way. These two. So for this one, if we were to zoom in, let's see if we can get it close. I think you can see it there. You'll see that a part snapped off right there. And the thing was, there was support material around it, and when we were carefully trying to remove it, because it's such a small piece and it is elevated quite substantially from its sort of mounting point on the part, it just snapped off. And so it seemed pretty much unavoidable, at least if we were trying to get all of the support material out. Similarly with these, a lot of the joints, they had support material in them, and as much as we tried to remove it out with pliers, because it's PLA, we can't sand it either necessarily, so it was really difficult, so that when we put in the pins don't actually rotate cleanly all the way. So sometimes it gets stuck a little bit, but it does fully rotate. It's just that it's not smooth as we would like it to be. So again, for future reference, definitely won't be printing with support material. And you can see, in contrast, the quality of the print of the hand itself. It's very nice, even for these 3D contours, such as the palm. And you can see I took off one of the gel fingertips for this fingertip, so you can see, look at the quality of that fingertip. But again, very smooth contours, not too many artifacts. Again, not too much. The layering, it's pretty well blended. Of course, with any 3D FDM printer, you still could see the layers, but again, it's very smoothed out, and from a distance, you definitely can't tell at all. So that is the good thing about this test print. A secondary issue we ran into was, because we did print this with thermoformable PLA. The good thing is that we were able to thermoform the gauntlet, as you can see. The bad thing is because PLA is so temperature sensitive, leaving the prosthetic in a warm environment for an extended period amount of time does cause it to warp significantly. So if you can look at the joints here where the gauntlet connects to the hand itself, you'll notice that it's not actually, sorry, it's sort of hard with this camera. Yeah, so right here you can see that it's not actually flush. And then same with the bottom one as well. And so the issue was that when we first attached it, it was perfectly aligned, but then unfortunately we left it in a warm area for maybe like half a day. But that was enough time just to completely warp it and then sort of mess up its shape. So while it still functions, it definitely loses some of its, again, fluidity and its efficiency when these parts start to have friction against each other and they don't rotate as smoothly as they could. Yeah, so those are the main two challenges, again, to sort of summarize. Again, don't print with support materials, and then secondly also keep it in definitely a cool environment whenever possible. Try to keep it out of the sun or really any warm environment whenever you can. One last challenge we faced was with the dental bands. This might just be an issue with the specific brand we bought from Amazon. But when we first printed it, you can see this finger springs back into place relatively well. That's because we just replaced these bands of the lower sort of knuckle joints right here. But you'll notice that with the, well, let's see, yeah, with the thumb and with some of these other joints, they don't actually spring back all the way, or fast for that matter. And the issue with the dental band is that when we first put them on, they were very elastic. They obviously sprung back into its original shape very quickly. But the thing we discovered was that over time, the dental bands began to erode, and so I think it's a little tough to tell, but try to zoom in on that middle finger. So you can see it doesn't actually go back. I can't tell if you can tell, but the dental bands, it's definitely not, it's not a smooth contour anymore. It's definitely eroded a lot, and so they just need to be replaced. So after this, we'll be replacing some of the dental bands, and I think we'll have to just do that periodically, at least for the time being, until we find either a new supplier, or that just, again, might be a property of the dental bands. But yeah, I think that covered most of the qualifications in the sample video that I was looking at. So again, if I missed anything, feel free to send me a message, post a comment, and I can, again, try to respond as quickly as I can. But again, one last time just to see fully closes. And really all the issues with the hand is again, just with sort of the printing mistakes that we made along the way. But yeah, thanks for watching.